I will go on with the tutorial about flow around the cylinder in the channel, channel. Last time we built a very coarse mesh. Today we'll make the mesh more finer using new very interesting program ICEM CFD. Okay, where is my lesson? 1 minute. I will use the same project as before. Oh, it's better to build new geometry. It's easier, more easy to do this, but to find previous project. Okay, I hope you see this. Okay, I have opened the project, the new project. At first I will build the geometry of the flow. Let's use analysis system, fluid flow, Fluent. I created new project. Right click geometry. No, at first right click and let's change the properties. Analysis type you should change from 3D to 2D. So geometry, properties, analysis type 2D. It is very important for today's problem. Then again, right click geometry, select new design model geometry, the new window is opened now. At first we will draw the sketch of our geometry. Let's use XY plane. by this button. Click it in the tree, then we'll go to sketching, and we will draw two circles with one center. First note, first let's change the units from meters to centimeters. It will be better for our task. So units, by default it's meter. Let's select centimeter. Now it's okay. So circle, go to this 0 point and draw one first circle. Then the circle with bigger radius. I think something about this. 2 times will be enough. And then let's build a rectangle, draw rectangle, which begins also in the 0 point. Okay, one rectangle and another. It is very important that the top point of this rectangle should, no, it's not okay. The top point should coincide with the circles. Oh no, it's not this time. Okay. Here we got the point on the circle, and the big rectangle is not okay. So I will destroy it. Or maybe no, I will correct these problems using another method. Let's make the dimensions. So I select dimensions. At first radius. R1. 10 centimeters is okay. And the second radius, I told you 2 times. Let's make it 25, a little bigger. 25 centimeters. Very good. Then the length of the small rectangle. In the dimensions I choose general. I select general. This one. H3 in my sketch. 30 centimeters. Very good. And this bigger rectangle, I think it should be much bigger than I have now. 60 centimeters. Now I think it's okay. Maybe even no, maybe even more. 80 centimeters. Now it's okay. We have a lot of lines, and some of them we should trim for building the geometry of our flow region. So let's select modify in the left upper part, the option trim, and we will trim some lines. The part of the big circle, only this part is left, and the same with small circle. Okay. Now this line, it consists of two lines or rectangles, so I should trim twice. One more line, two parts of this line also. Now I have this flow region, but it is not finished. We should connect these two points. So again I go to draw and connect this line, these points. I can do it very easily by line, horizontal line on x-axis, and again trim, modify, trim, and trim these parts. Now I have all flow region ready for building the mesh. But at first I should make the following operation. I choose this view, symmetrical, then select modeling, and concept, and the operation which is called surfaces from sketches. I will build plane surface from this sketch. Surfaces. Select sketch 1 as a base object and click apply. So the base object should be the sketch which I have built. Add material, yes, all by default, and now click generate. Now you see the computational domain in which we will build our mesh. What is it? It's the channel and the body inside this channel. We will try to simulate, calculate parameters of the flow which inlets from the left, flows around the cylindrical body, and very interesting part is base region of this body. Let's save the project. I have the special directory for this problem. I will call it maybe cylinder, and today's date, the 7th of October. Okay, the project is saved in this directory. Maybe we sometimes we can go to the mesh option in this project, but I will build, as I told you, more much finer mesh using another program which is situated in component systems and which is called ICEM CFD. Drag and draw it in the project field and connect geometry and the model. I click on the geometry and drag it into the model. Now they are connected. By this option, by this action, I imported the geometry from this part to ICEM CFD. Let's open the model. The geometry design modular, we should close this window. And now we are in the ICEM CFD program. Let's open geometry and click on points. We see the lines, curves. They are called curves in this program, and the points of our project. Now we will create paths on which in the future we will set up our boundary conditions. We have inlet, top wall, outlet, axis, base region, cylindrical region of our body, the front part of the body, a circle, and one more axis. So this will be our parts of geometry. Let's create them. Open parts in the tree. Right click on the parts and select create part. Well, let's begin from the beginning. Inlet, the name of the part. Then we must select entities. Click here. And we must use only lines for this project. So we will make the bodies and planes forbidden for the selection. Only the selection of curves should be active. All other should be closed. Inlet, as I told you, inlet is here. Click left button. Nothing happened. Now you see the text here. To make it selected, we should click middle button of the mouse. Now this part is called inlet and it appeared in the parts. The next part is top wall. In short, we will call it top. Left click on this line and again middle button. You see top in the parts. Then outlet. Select middle button. Axis. It will be axis 2. Axis 2. The name of this part. Click it, line and middle button. Base region. We will call it base. Click on this line. Middle button. Cylinder. I will call it simply CYL. Then the sphere. Front part, simply. Front of the body. Select it and click middle button. And the last part is axis 1. Axis 1. Okay. Now close the selecting of the parts and let's make the check of our parts. Axis 1 Okay. Access to base, cylinder, front, inlet, outlet, and the last part is top. Okay, all parts are correct. Now we must create body, so-called body for this domain. It's optional, but we will make this operation. Here we select create body, call it, for example, flow. The name should be different from the parts which we created in the previous part of our work. I will call the body flow and choose the centroid of 2 points. So I should select 2 points. The centroid should be located inside our flow. So select locations and select 2 points. For example, this point and this. And then again middle button of the mouse. You see that the flow point is the center between these 2 points, and what is very important for us is located inside of the flow. In case when we locate it outside of the body, it will be an arrow. Dismiss. The second very important part of our work is the creation of the blocks for this geometry. We must open this page, blocking. The only button which is active is create block. So let's create block. Very important, here should be the name of our body. The name of our body, you remember, is flow. So in this part we must have flow. Change the type to 2D planar. We are solving the 2D problem, so the type should be 2D planar, and that's enough, so click OK. The block is very simple, it's a rectangle, but we will modify it for our task in the following manner. Let me choose the best way of doing it. Okay, the body is not needed now, so we can make it invisible in the tree. Let's split our block into 4 parts at first. So again we are located in blocking. Choose the second button, split block. And we will split it by the edge. How to do it? Click on this button, select edges. We will select only one edge. For example, the top edge. Oh, it's not. You see, I selected the vertical block line, the horizontal line, and it created the horizontal line. I can move it. I locate it near the base region. To make this operation done, I should click again the middle button. Now my block is divided into two parts, left and right, by this line. Now I will make vertical, select vertical edge and try to build the line which is located near the cylindrical part of the body. And again, accept this operation by clicking the middle button of the mouse. Now I have 4 parts of the block, 4 blocks. You will see that one of these blocks is not needed. This block will be deleted. How to do it? Select the operation delete block. All blocks are numbered. In my case, the 4th block should be deleted. I select it and click the middle button. Now I have only 3 blocks. The next operation, again split an operation, split block, select edge, and I will split this block into 2 parts near these points.
Yeah.
Okay, locate it somewhere here, and the middle button. Very good. All operations with building blocks are finished. The next part of our work will be association the blocks and the geometry of the flow. Now we have 2 entities. One entity is our flow region. On these entities, on this flow, we have curves and points. And the second entity is blocks, which has vertices and edges. Now we will associate the points of our flow region with vertices of the blocks and the curves of our flow geometry with the edges of our blocking construction. How to do it? We have this button in the blocking page, which is called Associate. Select it And the first option is association of vertices with points. It is called associate vertex. Let's do it. It's very simple. How to do it? We will at first select the vertex and then the point where it should be, with which it should be associated. So let's begin. Vertex. Select this vertex and then select the point where it should be located. I select this point. You see that the vertex relocated in this point. The same here. Vertex, point. This pointed vertex seems to be associated, just already associated. I don't quite show in this part, so I click vertex and the point, and I see that they were not associated previously. The same here. This vertex and point. One click for vertex, the second click for point. Here the same. First click, second click. And here. And the last vertex is here. And the point here. I cannot now associate this vertex because there is no points for this which will be associated, but I will do it in another way in future. You see that we have no points here and no points here, only vertices, so no associations at first. 1 minute, I will show you it. You see there is no points here. Dismiss. Again, visible vertices and edges. Now the association of vertices and curves. It will be done in a little bit different manner. So, associate button. Select association of edges to curves. And I will explain it in a very slow manner. I click on the vertex, on the edge, sorry. This edge should be associated with inlet curve. I selected this edge. Now I should click middle button. The edge is selected. And then I click on the curve which will be associated with this edge. I select inlet curve. And again middle button. Now I have association between these two regions. To see it, to watch it, we may by this option edges, right click, show association. You see green arrow which shows the association of this edge with this curve. Okay, let's do the same with small circle. Select edge, middle button, then select curve, the front part of our body, and middle button. Now green arrow shows the association. And the same we must do. Sorry. I don't understand why. I have to enter again association because I clicked wrong button. Again, edge. We should associate all edges with all our parts. It is very important. Otherwise, we will have errors in the next step of our work. So let's go part by part. At first, the top edge. It consists of two edges. So I will select both. So edge, first part of the top edge, and the second part. And middle button. And I will associate it with top part. Select top part and middle button. Then the same with outlet. The edge again consists of two parts. I select two parts of the edges. Middle button done, and then outlet part. Great. Now axis. Here it is very simple part. Select edge, middle button, select part, middle button. The same with base. Cylinder part and the axis 1. Oh, I think I didn't finish with cylinder part. Again, select it. Oh. Very bad. Backup cancel, yes. I don't understand why I can't it. Maybe undo operation is needed. Edge, select it, cylindrical part, okay, now the axis 1 and axis 1 part. Okay, I hope everything is all right. Better to check it. So I think the association are ready. To finish it, we must select these buttons, swept project vertices, and click OK. All right. Now let's build. I will save the project on this study. Now we must build the first variant of the mesh. Let's do it by the following manner. I will make association invisible. We not need it now. Then go to the mesh page. For 3D problems, this button is usually used global mesh setup. For 2D, it's better to use this button, which is called curve mesh setup. We set up the mesh near the curves. Let's select curves. We should use all curves of our geometry. So click on select curves. We see this small window and we select all visible objects of our geometry. Spectacles. So you see that all curves now are selected. The maximum size. The radius is about 10, no, not about, is 10 centimeters. So I think that 1 centimeter for the first attempt is okay, 1 centimeter. We may make it smaller, but at first we will correct if it will not satisfy us. Okay, 1 centimeter. Oh no, in this case we must use meters. I made a mistake, sorry. Again, select curves, all curves. I selected one, but in the ICEM CFD only meters I use, so I should change 1 to 0.01, 1 centimeter. Okay. Now again return to blocking and select Premesh Params button. The first button, Update Sizes, should be active. Click Apply. And make active click on pre-mesh in the blocking in the tree. Display preview mesh. It asks us whether we should recompute the mesh. Always answer yes on this question. Now you see the mesh. It is very good for our problem. For the first attempt of the building. Now we may improve it. On the previous lesson I told you that it's better to make the size of the mesh near the wall very small in order to work with boundary layer. Let's do it. We again use pre-mesh params, this button, but now the active should be this button edge params. Let's select the edge where we will improve our mesh. The edge of the blocks, of course, not the curves of geometry. We will select this edge, make it closer, box zoom, let's select. Very important, you see the arrow, which goes from this point to this point. The point from where goes this arrow is the first point on this edge, and this point is the second point. So when we are using spacing, the spacing 1 is the spacing of the first, near the first point. The spacing 2 is the spacing near the second point. So the direction is very important in this case. Let's increase the number of nodes on this edge. Now we have 16. Let's make it about 25. I think it will be okay. Maybe 30 more. 30 nodes on this edge. And the first spacing, now it's about 0.205, 5 to 1000. Let's make it about 10 times smaller. I will make it 0.305, 10 times smaller. Ratio 1 is the ratio between the second and the first spacing of the nodes near the point 1. It is recommended to make it about 1.2. We will not change the spacing of near the second point, and click apply. Then rebuild the mesh. Again, clear the pre-mesh field, and then again click it. Recompute, yes. You see that the mesh is have the size much smaller near the wall, but it is not interesting. It's only near this point. I want it to be finer near all this wall. To do it, I am not changing the edge. On the same edge, I select the field copy parameters. To all parallel edges. You see, method to all parallel edges. Copy. Again, click apply. Clear the pre-mesh and again click it. Yes. Now you may see that near the wall of our body we have very fine mesh. Only the base region is not good for our calculation. So let's improve this situation. Select edge button. We will select another edge. This one. And I have 11 nodes. I think it's not enough. Let's make about 20, for example. 20 nodes. Let's make it closer. And I want to make the mesh, the side of the mesh in this part smaller near this point. This point is very important for flow analysis. So I will make the mesh finer near this point. The arrow goes from this point to this, so I will change the spacing to the point 2 is here, and I will change the spacing to, I will make it again 10 times smaller than it is. 0.305. The ratio to 1.2. What about copy? In this case, I don't want to copy these parameters to the right part of this edge. So I will clear the copy parameters. I don't want this size on the right part of my geometry. So I'll clear the copy parameters, apply, clear premesh, and again check it. Yes. Okay, I have very good mesh near this point in vertical direction, but I must make it finer also in horizontal direction. In this case, I select axis 1 edge, axis 2x, sorry, and change this spacing. You see the direction of the arrow, so the first point is here, and I will change the spacing 1. Now it's 1/200. I will make it about 1/1000. 0.201. The ratio again, ratio 1 is 1.2. Apply. I think that it's not very good. I should copy parameters in this case, because I want also on this edge the same parameters. Copy parameters, apply, and again rebuild the mesh. Oh, now it's okay. For this point we have very good mesh near this point from the right part, but not from the left. I think I must improve also the sizes of the mesh near this point on the cylinder. How to do it? Select this edge, "31 nodes." Let's increase it. 50 nodes, for example. And I want to decrease the size near this point. The arrow is directed from this point to this. That is why I will operate with spacing 2. I will make it the same as from the right side of this point. 0.201. The ratio again 1.2. To copy, yes, I will copy the parameters, so this field should be checked. Apply. And rebuild the mesh. Very good. The sizes of the meshes are very close to each other. And the last operation which I will make, I have a small sizes here. It's not good. I will change these the sizes of this edge. What do I mean? I select this edge, clear the copy parameters. I don't want to spoil the previous operations. Only this edge will be changed. And in this case, I use all parameters 0. When I put 0, it will be the numbers will be default, will be chosen by default. Apply. The real sizes are all the same. And rebuild the mesh. Yes. Now I think the mesh is perfect. Okay, now the operation of building the special mesh. We built it mesh for our blocking system. Now we should import it, export it to the Fluent solver. So let's close the premesh params. And now we will make the following operations. We will do the following. Right click on premesh. And select the operation convert to unstruct mesh. We have built the structured mesh, but the Fluent uses unstructured mesh, so we must convert our mesh to unstructured mesh. The mesh has been already built, but now we must replace. We build it new mesh. It was built by default. It is not good mesh for sure. So let's click replace. Now we have unstructured mesh. You see that the premesh is cleared, but we have the mesh option and shells. The shells are associated with unstructured mesh. And the last option, a very important option, is to export it exactly to the Fluent solver. So select output mesh, select solver. By default it's ANSYS Fluent. Let's click apply. It's okay for us. The second is very important. Open these boundary conditions. We must make sure that our edges are all associated with our paths. It is very important to make it sure. Axis 1, axis 2, base, cylinder. the flow, its body, the front, inlet, outlet, and top. If we didn't associate any edge to the parts of our geometry, we will get the arrow in the next part of our simulation. When we'll try to solve the problem, we will get an arrow. So click accept, and the last option is the building of input of the mesh file. Save current project first, yes, okay. Then default name of the file, okay. And now we must change some options. By default it's 3D, we have 2D problem, so change it to 2D. And by default the file is binary, but we want it ASCII file, so text file. And now done. Okay, I think no mistakes, no errors. But let us look at this file. Let's look. It's located in our problem cylinder. Here the files dp0, ICEM, CFD, and the file with MSH extension. Here is the file of our geometry. I will copy it. Let us look inside this file. The most interesting for us is the last part. We must make it sure that we have all parts for our boundary conditions. If we have an arrow during association of edges and curves, we will not have all our parts. So let's go inlet, okay, top part, outlet, axis 2, base region, cylindrical angle, and front. And the last part is axis. I think the file of our mesh is ready for making simulations. Let's save our project, close the ICEM CFD window, and finish our today's lesson. On the next week we will use this mesh for our simulation of the flow in different cases. Now I will finish the first lecture. Let's make a break.